Morning. That doesn't sound like the coffee has settled. Morning. Welcome. My name is Lukman, and I'm the technical writer for Para Services Limited. So today we are going to look at a quick hack, not a hack, but incorporating AI into Jakarta EE applications. How many people here have heard of Jakarta EE? Oh, nice. So you are all already at home. I don't need to start from J2EE and how we are at Jakarta EE, so we can just dive in. Now, who here hasn't heard anything about AI before? Who here hasn't heard anything about AI? Okay. Who here believes they really are not AI generated? If you are sure you are not AI generated, raise your hand. You are real. See? Nobody's sure they are AI generated or not. I was just kidding. Okay, so AI. The Python community has done a lot of work to incorporate AI into the various Python frameworks. And in the Java world, we have Spring that has the Spring AI API. And so the question becomes, Quarkus also has a deep integration with AI. So the question comes, where is Jakarta EE? Well, Jakarta EE, as usual, is always there. It gets out of your way and then gives you what you want. So let's start. AI Jakarta EE, a quick primer. We are all aware, but we just need a quick primer. So generative AI primer, AI systems based on large language models trained on massive data sets like internet scale data sets that can generate novel content, in theory, novel content, text, code, images, in the future, probably human beings. Who knows? Don't know. What is RAG? Now, AI is good, as we stated in the previous slide, for generating new content. Now, in organizations, or many organizations now, like Microsoft, Google, they are all moving towards having users have interactions with their documentation. So one of the ways you can do that is if you are the Google skill, you could take a model, a base model, and then train it with your data, your internal data, like the Jakarta EE documentation, for instance. You could train the AI model on that. Or if a small organization like Payara, you could do retrieval augmented generation. And this is pretty much taking your data, embedding it, and then using it as a sort of a bridge when there's a query to the model so that your users can have natural language conversations with your documentation. And that is exactly what we are going to look at. So RAG, retrieval augmented generation, pretty much combines LLM with your own internal data. It enhances accuracy through context retrieval, so you can have your users ask questions about your documentation, because as your systems, your product, your whatever grows, you're going to have a huge documentation set. And it's going to be time consuming to have users go through and find out some obscure use cases. So retrieval augmented generation is a great way to get users to consume your documentation without needing to waddle through content and menus and all of those. Now, it also helps in reducing hallucinations, or as Microsoft argues, we shouldn't say the LLMs hallucinate, we should say they fabricate. Because Microsoft has warned us that we should not try to anthropomorphize the models. They are not humans, they are not sentient, so we shouldn't associate LLMs with things that human beings naturally do. So we should say fabrications. So RAG, or retrieval augmented generation, helps reduce fabrications of the models. Okay, so why RAG? It's cheap, it's easy, maintains data privacy, it's traceable. You can trace and know where the problems are when there's responses, because you can trace all the way to which embedding data was sent to the model. It's very, very fast to implement, as we'll be seeing. Very, very, very fast. And then generally, there's the lower computational cost, because running LLMs, training LLMs with your data can be very expensive. Now, what is the architecture overview of the sample implementation that we have? It's a completely zero ops deployment model. We are using Payara Cloud for our deployment. Neon database. Neon is serverless, if you can say that. It's a serverless Postgres hosted database. So Neon will host our embeddings, and then Azure Blob Storage is going to be where we'll just drop our documentation, and then our application is going to constantly cycle, sort of monitor that container directory, and then if there's any documentation, it's just going to pull it in, embed it, send it to the database, and then move that documentation from that folder. So pretty much 24-hour, you're just going to have your users or your administrators drop any new documentation into that storage container, and then your application is going to pull it, embed it, and then put it in the embedding database. Okay, so the application flow, as I stated, startup, scan the Azure storage container, process the documents, if there are any, process it through the LLangChain4J library, store the embeddings in the Neon database, move the files, and then pretty much we are done. So there are two components in the sample code. We have the embedding service interface, which is an interface that you can implement, so you can have different implementations for the embedding service. In this case, what we are doing is using the OpenAI API to create the embeddings of the documentation. You can implement this interface differently, so you can have different implementations. In development, for instance, you could use a local LLM to do the embeddings. I find the OpenAI API pretty much easy to use and also cost efficient, so I prefer using that directly instead of running containers on my machine. And then for document management, we also have a document management embedding document loader interface that you can implement. So you can implement this to scan anywhere for documents, either a local directory, or if you're in the cloud, you could scan AWS S3, though my experience with S3 has been very questionable. AWS S3, or as I chose, Azure Blob Storage or any other service. And then pretty much that is it. So before we dive into the code, let's see it in action first. Now, if I go into my Neon console here, you can see this is my database. My database is called EclipseCon. Sorry, Eclipse. The database is called EclipseCon. It should have been OCX, but sorry. And then I'm in my database. So the database has the embeddings table, and you can see it's empty. There's nothing in there. And so there's nothing in here. This is my storage, my Azure storage. The storage container is also called, sorry, Eclipse. It's called EclipseCon, and there's nothing in here at the moment. So nothing in here, nothing, no embedding data. If I go into our model here, and then I ask it any question pertaining to, let's say, PyraCloud, for instance, it's probably going to give me generic answers because it's going to be based on general data that it's been trained. So let's try that. Let me see, how do I set up custom domain on PyraCloud? Now remember, the whole point of retrieval augmented generation is to sort of train the LLM with your custom information. Now you can see it spat out some information here. And again, this is a result from OpenAI's GPT 4.0, 4.0 Omni. I'm not so sure what the name is. It's so many of them. So this is from the OpenAI GPT API Omni model. And you can see it spat out a whole lot of stuff here. Now, let's go into my Azure storage directory here, and then upload a custom documentation here. So I will paste this here, say open, and then upload this. So now I am uploading the document, and this is the full PyraCloud documentation. It's very simple, very small, because PyraCloud itself is a very small product to solve a very big problem. So I've uploaded it here. Now, after a while, if I refresh this page, you wouldn't see anything here if the model is done embedding this. But before then, while it's doing, let's go into the code. So this is the embedding document loader I showed you earlier. This is the interface. And I have a very simple implementation in here, which is the Azure Blob Manager. Now, this is where Jakarta EE comes in. This interface is a plain old Java object implementation here. And the only time you see things about Jakarta EE is just the CDI and then the micro profile config properties that we are using to externalize nearly everything. The SaaS token, the SaaS URL, the Azure authentication stuff, they are all things that are externalized to the application. Of course, you don't want to check in a URL, a key, or anything, something like the Azure storage container URL. These are things that you don't want to check in your code. So we use the micro profile config to externalize this very sensitive information. So we have this here, and we have our implementation here. We start by creating the blob service client. This is the Azure Java SDK for the Azure container storage. So we start by creating a blob service client, and then from the LLangChain4J API, we are directly using the Azure blob storage document loader. And then we pass in the blob service client, and then this does the rest. So pretty much for this class, the document embedding document loader, this is all we did here. We just implemented the methods through the LLangChain4J Azure blob storage document loader. Yes, this is Java, true. So Azure blob storage document loader, we just implemented that, and then pretty much that is it for this class. And this class here is doing that. We list the object, move the documents. After it's done embedding, we load documents, or you can load the document by the document key. And then we have the embedding service. This is actually where we take the documents that we get from the document loader and then go to the model to create the various embeddings for the model. So let's go into this implementation as well. So this is the implementation for the embedding service. Here is a Postgres embedding service. Of course, you can have different embedding services. You can have Postgres, you can have Oracle, you can have even in-memory embedding service. You can store the embeddings in memory and all of that. LLangChain4J has support for all of that, but here we are using the Postgres service. And then what we are doing here is creating a data source, a plain old Java data source, and then some small micro profile config trickery that Pyara supports. So in here, in the JDBC URL, this is from the micro profile config, and this here is a custom support that Pyara has, where we can drag things or we can read things from a config source directly in the annotation. So we use this small trickery here to pull in the database URL, the user, and then the password. Because again, you don't want to even accidentally check in this in your code. So we externalize it with microprofile. Who here hasn't heard about microprofile before? Okay, so 2 minutes, I'll tell you what microprofile is. Microprofile is a subset of Jakarta EE or Java EE or J2EE. Hopefully you've heard of that one before. Okay, so microprofile is a subset of Jakarta EE with modern APIs for creating cloud-native Jakarta EE, Java EE, or J2EE applications. So it has one of the APIs, very popular, very powerful, my favorite, is the config API. What it does is that it allows us to externalize configurations to the application. So in this example, for instance, so let's come down here. This example, as you can see here, I'm externalizing the OpenAI key and simply reading it from a config source. So microprofile, the runtime, the implementation is going to go to the various config sources and then look for this particular key for a configuration value. And then if it finds one, it's going to read that and inject it into the value, the field there. Pretty much that's all it does. So that is what microprofile is. I encourage you to check that. It's a great project that augments Jakarta EE for modern development. So back to our Postgres embedding service here. We have this microprofile magic that we are doing to do the embedding. And over here, we are creating an embedding store. The LLangChain4J project has different embedding stores. It supports different embedding stores. One of them is the PG Vector embedding store. There is the PG Postgres, where it's a library, not a library, an extension to Postgres that allows you to store AI embeddings or LLM embeddings or however you want to call it. It allows you to store embeddings into a Postgres database. Embeddings is just a numerical representation of text. You and I read text, but the models, they are very base, very advanced mathematical magic that only understand numbers. So the embeddings is simply taking the text that we have and then creating their numerical representation, and then we store it in the database. So we create the embedding store here, and this here, as you can see, we are passing in the data source that we created up here. So we use the data source definition to create the data source, and then here we simply read it in. So this is pretty much bound to a GNDI, this GNDI name here. We inject it down here, and then simply read it. Now also, this here could have been externalized to the runtime. If I'm going to have different applications use the data source, I could have externalized it to the Jakarta EE implementation, in this case Pyara, and then simply read it from there through this injection field here. But for those purposes, I would just, this was simpler to demo. So down here, we just pass in the data source to the PG vector builder here, and then we have our embedding store. Then the model, we are using the OpenAI embedding model. Again, the type of embedding model, OpenAI has a lot of them. This one, again, this is externalized through microprofile config. Here, we read that in, and then we create the splitter. The splitter is pretty much a LangChain construct for splitting large documents into chunks. So we are splitting it into a max segment size of 100 with the OpenAI tokenizer here. And then here, this is the ingester. This ingester is in charge of or responsible for taking the embeddings and then putting it in the data store, so to speak. And then pretty much that is it. That's all we are doing here. And then we have a Java timer here from the java.util package. Now, in the past, I would have used from Jakarta EE, I would have used the EJB API. I would have made this a singleton and then annotated it with at startup. But as you can see, this at startup here is from the Omnifaces library. It simply starts up at startup application deployment time. This annotation causes this bean to be eagerly instantiated and then makes it an application scope bean. So why I do that is because at startup, I need this bean to start up eagerly during application deployment startup and then start scanning the directory, because once deployment takes place, you could have your users go in and upload documents to the storage. So this bean should start up eagerly. In the past, I would have used EJB, but the Jakarta EE project is currently transitioning a lot of the EJB features to Jakarta CDI, and that is exactly what we are mimicking here. And then down here, you might also be wondering why we are using the Java timer. It's because, again, EJB has its own timer features where I could have annotated this method that I'm interested in here. With a timer, I could say run this method every 2 minutes or something. But again, since we are transitioning from EJB, and please don't run out of the room. Those of you who know EJB, don't run out. We're not using EJB here. Who here has heard of EJB before? Yeah, no horror stories, no EJB here, pure CDI here. So we are safe. Don't run out. So the timer here, we are setting a timer to an initial delay of 2 minutes, and then at an interval of 60 seconds, every 60 seconds here, run and scan the Azure Blob Storage container. And this method is what is doing the chunk of the work. We start up, read any available document, we read the document in, iterate over, and for each document, we create an embedding and then store it in the embedding store. So if you remember, we had uploaded a document. Let's come back here and check our progress so far. If everything has gone according to plan, the document should be moved from here. So you can see the document has been moved, and then it's been moved into the embedded files folder. So this here now has been embedded. And now if I go into my Neon console here, I should see something. So these are the embeddings. It has taken the document, created the various embeddings, and it's a lot of numbers and me and you will just see it as, yeah, just numbers. But this is how the model understands the information that we are sending it. So pretty much here, this is the embeddings, and these are the chunks. Remember, I told you that the LangChain library has this construct for breaking down large documents into various segments. So these are the various segments of the document that we created. So each segment has its embedding. The embedding is just the numerical representation that the model understands, and then we store it, and then some metadata here. So this is all of this, again, in the Neon Postgres database. I didn't run anything because DevOps is a lot of work, very hard work. I'll spend that time writing Jakarta EE data code. So here, everything is in here. Now, if we go back, and then again, as this guy, not this guy, this model, I'm anthropomorphizing it. How to, what was the original question? I will just copy this, word for word. If you have any question, you can ask me. I wouldn't wait for questions. I always like you to ask. Any questions so far? Any question? Sure? No question? No question? This is very boring. Either I'm doing a bad work here, or I'm doing great. I'm not so sure which it is, but there should be some kind of questions. Please, ask questions. So let's ask the same question again and see if there's any kind of difference in the answer. Again, post this and then ask this guy. Okay, probably need to refresh. And then ask this guy. Okay. But of course, you see, something, it's not working. It wouldn't work. No idea? Okay, so let's run this locally. I would come here and say docker compose app-d. It's always like that. You just prep locally and it works, and then you are displaying, and then something just breaks behind the scenes. So yeah, so Maven clean package, and then copy this to my deployment folder. So what I'm doing here now is running everything locally, not everything, just my deployment here is what I'm running locally. No Docker for any LLM or anything, just here locally. Now, again, we have everything already in the data store here. So if I run locally, and locally also it's connected to the data store. So if I run everything here, I should generally have the same result here, of course. So deployment is taking place here, and this has successfully deployed. So I can go here and say remove everything here and say localhost 8080 and say GPT. What? No, I probably missed the URL. :8080. No, I missed L. Local. I always miss an L. Good. So /JEE dash chat GPT. Okay, so back here, and then I would paste this guy in. I mean, wipe here. So here, you can see there is a different result here than what we had. Anybody seen the difference? In the past, it was much generic, like you go and buy a domain. Of course, I would buy a domain before I'd want to assign it. I know that already. But it says go and buy the domain, and then, yeah, those were. But now you can see it's much more focused. I don't know if anybody's noticing. It's much more focused, telling you go here, stand here, sit there. So it says add a new domain, look for the button indicated in figure 30. Now, this here is a bug. Again, if you go back to the slides, it says that there's traceability. So we can trace this to a specific part of the documentation. So if I go back, if I go to pyara.cloud, and then I go to here, where's my internet? Yeah, Good. If I go to Learn, and I say PyraCloud, if I go to How-to Guide, Application Management, Advanced Features, and I go to Custom Domains. So this is where that information is coming from. So add a custom domain. On the next screen, click this, enter blah, 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 set custom domain, blah, 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 blah. Here, oh no, not here, there, here. So this is where some of that information is coming from. So click the set custom domain button. This action will direct you to the custom domain screen where you find it necessary. This is from the documentation. And we are getting that information here. So on the DNS information screen depicted in figure 32, of course, there's no figure 32. You will find the information. Now, these are some of the things that, in this case, we can go back in here. And then, in terms of correcting some of this, also, before I go in, you can see our timer is running. So this is constantly scanning. So it says starting document embedding service here. And then about to embed found blob object. There's nothing now in the container storage, so it's empty. So this is running every minute. You can customize this. This has been externalized here, so you can customize this. So initially we said wait for, when the application starts up, wait for 2 minutes, and then 2 minutes after, now start scanning every minute, scan the Azure directory, and these logs here are what we are seeing in the server logs here. So again, back to this issue of, where is this guy? Here, back to this figure 30, blah, blah, blah. We can go in here, and I can go to Pyara chart, this guy, here. So this is the LangChain feature, the AI services feature. We create an interface here, and then with some annotation. So this is a system message that we are using. So we are using this system message. Now, one of the fastest way of fixing this is coming to the system message, and then you can now tell the model as a system instruction that don't make references to figures, for instance. Don't say figure A, figure B, figure C, and all of that. And this is the fastest way you can fix some of these things here, because obviously there is no image here. There's no image, there's no figure here. So in the reply, if you say, tell the user, go to figure, blah, 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 okay, where's the figure? So we can do some of these corrections in there. Any questions so far? There should be a question. Please, somebody should ask a question. No question, we are not closing today. I can talk all the way to tomorrow morning. No question? Iva? Oh, okay, I will take consolation in that. Okay, so pretty much this is how you can leverage the AI large language models out there in your own application, especially, again, as a technical writer, again, in documentation. Because most of the time, we spend a lot of time writing documentation, and users just don't read. I mean, you go to a forum or you get an email, support email or something, and you are being asked questions that are literally in the documentation, but people just don't read, especially if the documentation is huge. Has anybody seen the AWS documentation for any of their services? It's a monstrosity, you know? So these are some of the ways where you can incorporate large language models, but of course, not every company has the budget of Google or Amazon to take a model, fine-tune it, and do all of the steps to get a custom model. Retrieval augmented generation is a very fast way to get up to speed. As you can see, we did very little. We uploaded a document here. It got embedded into the database, and then pretty much we got a different result here. Pretty much, we got a different result here. So this is a simple way you can get started. And back to the code, since we are developers, you can see one of the powerful things about Jakarta EE is that it's an aircraft carrier, but it sits out of your way. It's huge, it's powerful. But as you can see, if you read this code, you really wouldn't even know I'm using Java EE, or this is a descendant of J2EE. You wouldn't know, because there's practically very little of the underlying framework in the code, other than the few CDI annotations and the micro profile config API that I'm using. There is very little of Jakarta EE itself here. So this is one of the good things that personally I like about Jakarta EE, because it gets out of your way. It's practically out of your way when you don't need it. And then when you need all that power, all that aircraft carrier power, it's available for you to use to solve whatever complex problem you have. So this is a simple way incorporating LLangChain4J into your Jakarta EE application. Again, to recap, we use the LLangChain4J in the embedding service here. We created an embedding store. In this case, we are using PG Vector. Again, LLangChain supports a lot of embedding stores. We use PG Vector, and then we use the OpenAI model to split and embed the document. And then pretty much that is all we did. Now, in the chat service here, the AI services, here, we didn't do much. LLangChain is doing a lot of the work for us. So that interface that we created, we don't have an implementation of it. It's pretty much like Jakarta EE, where if you create an entity manager interface, you don't implement the entity manager interface. There is an underlying runtime that is doing the implementation, an underlying implementation that does all the work for you. It's pretty much the same. So this interface here, I don't have an implementation of it in my code. The LLangChain4J library gives me an implementation of that. So here, I'm using their AI services to simply create an instance of the chat. And that is what we are using in the code. So LLangChain4J pretty much is like Jakarta EE, where you have interfaces that you use in your application, and the library at runtime creates the implementations for you. So as you can see, it's pretty simple. There's not much here. At startup, I'm taking a content retriever that we create in our embedding service, and the content retriever is pretty much just that. When you ask a question, in this case, when we asked a question here, the content retriever took our question, went to the embedding store, went to this guy here. Of course, we've created a data source, so there's a connection in the application. The content retriever went to the data store, looked for the closest match to the question that we asked, took those embeddings together with the question, and then sent it to the model. That is what the content retriever does. Or, yeah, that's what it did. So it just takes your question, goes to the embedding service or embedding store, looks for the closest match, takes all of that, and then sends it to the model. So now the model has your custom context on which to build the reply or the response to the question it's asked, and that is what we got in here. So back to this guy here, that is all LLangChain4J is giving us here. You can see it's pretty bare bones, but there's a lot of magic taking place in here. And again, CDI is being used to inject the various components. Again, we don't want to decouple, we don't want to do new. There's no new in Jakarta EE. If you do that, it should be illegal. So there's no new. We are doing at inject all over the place using CDI, microprofile config, and then the LLangChain4J in a very, very loosely coupled way. There is no coupling, there is no, pretty much everything is out of my way, and there is just the code. Again, this is very readable, easy to understand, and much more importantly, easy to maintain. Any question? Any question? No question. So I have a minute to go. Last recap, Jakarta EE is very good and ready, because most of the time when you talk about AI and Java, it's either Spring AI or it's Quarkus, but Jakarta EE is there and ready for you to incorporate AI into your applications. Again, it's an aircraft carrier. Always remember my analogy. Jakarta EE is an aircraft carrier because it's big, it's powerful, but it's always out of your way when you don't need it, and it's there to serve you like a genie, and then it's there to serve you when you need it. So as you can see in our sample code here, everything is decoupled. There is no tie-in. You wouldn't even know we are using the great-grandchild of J2EE. It's very simple. And then LLangChain4J is also a great framework or a library for incorporating AI in your Java and enterprise Java applications. Thank you. No question. Nobody asked the question. I feel hurt, but it's okay. Yeah. Thank you. Thank you. Thank you.